Okay, good morning, everyone. We are from a group for sentiments analysis. And so first, let me introduce our group members. My name is Ouyang Chen with metric number 204875, and my partner, Shafinas.
My name is Nisha Gudesal, and my metric number is 04711.
My name is Manan Ahmed, and my metric number is 205094.
Fiona, please introduce yourself.
Okay, my name is Lisa. Metric number is 204865.
Okay, so I will start the first part. So first here, this is for importing some necessary package. And for here, this one is for reading the training data sets. And the head function is for showing the structure of the table. And for here, this is the shape of the table. And here, this is counting for each different emotions here. And because we only want to classify them into 3 categories, which is positive, negative, and neutral. So we define a combined functions for combine all of the positive, negative emotion. So here, this is a combined one. And for here, this is for reading the testing file, and same operation. So I think that's all from my parts, and I will pass the next part for Fiona. So Fiona, can you please explain from the text cleaning set?
Okay, so for text processing, the first one we need to lower all the lowercase all the text, and then we do the regular expressions and use the import, and we also need to remove the digits and the words contain yes, and so for next processing step is extend the shortened words, and also we need to remove non-sensing words, and remove some functions, and then also need to remove the actual spaces, and use the import space to import this library, and also remove the stop words and then limitation. So after processing the text, we do the final. We do the data side to the another final text, another document. So next part I think is for word cloud. Skill can manage to explain it.
So now going to the word cloud. So this code is going to take all the dataset that we have imported and then classify it and make a word cloud. So can you hear me?
Oh, sorry. Yeah, I can't hear. I think it's my connection.
Okay. So the word cloud will display the most coming words in big font and least coming words with a small font. And then we're going to make a cloud, a graph. This graph, we have 2 graphs. This code will display 2 graphs. The first graph is about the original data set, which not have been processed yet, which is the most common words. And then against it, there is a graph with the with the new data set we have processed it with the most common words as well. And then after this, we're going to go to the, can you go down a bit? So the first word cloud would be about a positive emotion. And as we have said, the display the most common words in big font, least common words in small font. Then going to the negative emotion, and this is the word cloud for it. And then going to the neutral emotion, and here it is the word cloud for it. And then going to the pie chart. The pie chart will display all the emotions and the percentage of all the emotions. We have neutral, negative, and positive. For the negative emotion, it displays that the words are 37.4%, positive is 43.8%, and then neutral is 18.7%. And then mapping the least common words. And here is the graph. As the previous graph, we're going to compare the original data sets with the new data set that we have already processed. And here is the results. Now going to the next part, which is going to be presented by my friend Shafinaz.
All right, thank you, Mana. So basically what I want to explain is more onto the coefficient matrix and how we actually can use the data set to train it and then test it out towards the prediction. So first of all, we'll be converting the words into vector, so we can actually extract from the sentences of the sentiments and conduct some analysis based on it. And then we're going to split it into training set and also test set. And we have X train, X test, Y train, and Y test. And then the next thing is we're going to import the naive bias, and we will be fitting the X train and also Y train into the model. And then the next one, we will be running the training and then measuring the accuracy. So currently we have a 56.8% of accuracy. And then the next one will be classified into coefficient matrix, and by using the Navier Bayes model. And you can see it from here that the frequency of the predicted and also the actual number analysis of the sentiments. And we also classify it into precision recall and F1 scores. And as you can see, he actually quite high number of precision recall and F1 score, which is over 50%. And the next one will be using the SVM model to train the test set and the X train and also Y train. And by using 10,000 of iteration, we try to use the whole iteration of the data set, but however, it will take a long time for it to be run. Therefore, we only use 10,000. And then, so after that, we training the model, we managed to achieve around 75% of the accuracy. And then we'll be converted into the classification report, which in the graph, we can see here that the frequency of the actual and also the predicted sentiment analysis. They also classify it into the precision recall and also F1 score. And as you can see here, it have a very much higher score compared to the previous one, which leading into a higher accuracy. So meaning that by using SVM model, we managed to predict a higher number of frequency of the sentiment analysis compared to the actual one. So I think that's all for this demo. Thank you for listening.
Okay, thank you.